methodological session. The first speaker I want to introduce is Alex van der Helm. He is going to give a talk about model-based control in the urban water cycle. The interesting thing of Alex van der Helm is that he has experience in all fields, more or less. And at the moment, he is working at WaterNet, the end user in water. Before, he was working at DHV as a consultant in water, and he also did his PhD at the University of Delft as a researcher. So Alex knows everything from different parts, and now he is going to give us an insight in how he thinks model-based control in the urban water cycle should be arranged. The floor is yours.
Well, thank you, Luc, for this kind introduction. Well, luckily not everyone left the room, even though this will also, hopefully, this whole afternoon program is very interesting. First, I would like to point out to you my co-authors, Chris Ruiken, also from WaterNet, Kim van Schagen from DHV, and Luc, our chair from the Delft University of Technology. Well, first, I'm missing two how you call it, pictures. It's kind of a questionnaire. You can fill them in yourself. We see drinking water. We miss someone drinking it. We see our rain coming into nothing, which obviously should be pipes, and that goes to the wastewater system, and eventually it goes to our surface water. Now I told you already what it was, but this is the water cycle as we look at it from our perspective. And within this water cycle, we have different types of water, different types of water quality. We have many points of control where we can actively make a change within our processes or systems. We have many process interactions within these processes, within these systems, with very different time scale in chemical processes, ranging from a few seconds or minutes to in the larger systems to days, weeks, months, and even years. And we also have within our current water cycle highly developed instrumentation, automation, and control. And if we look at some examples of the last bullet, then again we have some missing links. But we have, for instance, modeling. We have process automation, process information systems, analyzers, instrumentation, our SCADA control system, control centers. There's quite a lot of sophisticated tools already within our systems that we control. And what I would now like to state to you is that the possibilities of integration. If you were here yesterday with the opening of Jan Peter, he said the main focus is to work towards integrated water solutions. And the improvements that are there are, to my opinion, numerous. But however, due to complexity of these integrated system, I also think that improvements can only be achieved very efficiently if you have a model-based approach. And what I will mean with a model-based approach, I will tell you in a minute. If you are talking about a model-based approach, you should have a vision and a strategy. It's a prerequisite in order to start working on this field. And what you've seen up till now, we have done really a lot, and that's what I will show you also later. And it's now a good moment. We saw just a beautiful vision from our young water professionals. And I think we also have to develop this in this field. And my idea was, well, they just started with the vision. I first thought, well, let's do an inventory and see what we are already doing in the water cycle of Amsterdam. So I'm going to show you a few of the examples that we have already worked on. But before you start doing an inventory, it's good to have a kind of a categorization of what you're looking at, because what you saw right now and what you know is that there are many forms of model-based operation. So I made this division into 5 categories. So what you can do with models, you can do model-based control, monitoring, optimization, training and design. So this is a categorization that I developed based on an earlier categorization that Kim van Schagen did during his PhD. And part of these model-based operations are offline, and part of these are online. So if they're online, it means that they have a direct interaction with your process, and they usually will run in an environment very close to your process automation, and in some cases you cannot always access them from your office because due to security measures, for instance, you cannot access them directly. And offline model-based operation activities usually are in an office IT. Some examples that will give a better view on it. So an example of model-based control that we are now have actually running within our company is Proost. And that is it's in English it's cheers. It's an how you call it, an abbreviation. And Proost, what it does is does demand forecasting of the water usage of drinking water in our water supply area. And as you can see in the picture on the left, this is I borrowed this picture also from Kim van Schagen from DHV. And you see all the days of the week. So the drinking water consumption in all the days of the week. So you have red for the Sunday. So everyone how do you call it? You see everyone is late in the morning, and on Saturday is green. It's a little bit earlier, and during the weekdays people get up even more early. And this we use in order to control the production of our drinking water directly. Another example, this is a development of Witteveen and Bos, is an aeration control based on an artificial neural network of our aeration at the wastewater treatment plant Westport. So it predicts the oxygen set point for the activated sludge process. And what we see is that it gives benefits in energy, nitrogen and phosphate removal. Another application that has just become running this year is the control of our sewer system. And Kees de Korte will tell you a little bit more later this session. Oh, I'm missing a picture here. That's truly pitiful, because these next three slides have 3 following pictures that were really the center of my presentation. Now, I'm lying. That's not true. But what is true is that they were very that's a difficult English word. Illustrative. I'll get there. I'll explain it to you. It's a good test for me if I can also explain this without the pictures that say it all. So whether I can understand it myself. What we did, you can derive a very simple model. It's if you go to pellet softening, what you do is you take out calcium by dosing caustic soda. So it's a fairly simple chemical reaction, and you do this in a reactor. And if you now say you look at this equation, so an equation is a model, so we have a model here already, and it says if the hardness that you remove, so the amount of calcium that you remove, if you double it and you take the alkalinity, that's the M number, and you add the caustic soda, and this should be equal. So you can make a nice line of this model. And then we tested this model within our pilot plant. So this is work from Kim van Schagen also, as you can see. And in this pilot plant, it was automated, and we could do thousands of experiments. We could just program them and go to a nice conference in favor, not in the Netherlands, but somewhere else, and let these experiments run. So we collected an enormous amount of data, and you could see that in the pilot plant, where we put a lot of attention in how to measure this right, you see all these dots are almost perfectly nice on the line, as you in this case cannot see. But if we go to the next slide. Oh, this is nice. So, well, so far for the test for me. But if we now go to the full-scale plant, we also looked at the same data with the same model, and we took laboratory measurements. So samples taken under really good conditions. All these chemical parameters have been measured, and what you see is that also the majority of the measurements are also on the line. What you could have seen if we had the other picture is that in the pilot plant we also had a lot of data here and a lot of data there. If we now go one step further, and well, this will be a big surprise. Yes, and we look at an online measurement that is actually in the full-scale plant, then you see that there all the data do not coincide as well as the model would. So actually, what you best could advise here is to only use laboratory measurements, take this model, and based on that values predict what your calcium removal is, and don't use an online sensor in this case in your real plant. That seems a little bit awkward advice from someone who's saying that you should measure everything online and know everything. It's also a little bit more nuanced, because what should be the case is that you have to develop really good protocols how to make sure that your online measurements are accurate. So, and one of the things also that we have learned, not only through this project, is that we indeed in the last few years had someone of the team of the drinking water production, and it's a large part of his job to develop this protocol and to have it well executed. And then you won't find these kinds of data sets that are very off what you would expect based on a model. Another example. This is an example of model-based optimization. So what you see here is that we collect historical data and real-time data and predict for instance, surface water levels. And what we do is that we optimize our water systems, and this is done offline, so we don't control any pumping stations or yet with these systems, but what we do optimize is water heights in our waterways, for instance, the volumes of our water bodies, and the capacities of the pumping stations for our within our water system. And this is also well, commonly used in the Dutch water sector. Another one, which is also a nice example, that's model-based training. So we have done this on two levels. On the level of water quality and on the level of water quantity. So we have, if you see this picture, oh, that's the wrong button. This looks like a SCADA screen, so a screen where an operator is sitting behind when he operates the facility. And you see all kinds of pumps and settings. And this is built before a new control in our drinking water treatment plant was implemented. So it was going to be different than what it used to be. So first this model is built that with the same control, operators were able to test how the facility will work, and afterwards it is implemented on the real plant, and they already had experience with how the system reacts. The second picture you see in the lower left corner, that is a simulator that we have developed in the last few years, and it is a plant-wide simulator. So of our drinking water treatment Wees per Karspel. So Wees per Karspel consists of several drinking water treatment processes, and they are in this plant-wide simulator. And we have also incorporated some real-time data with a connection to our real-time database of all our online information. And as you can see, we have kept our real-time total hardness measurements that I was earlier advising to take out of action. And what you can do with this is also that you can, for instance, train operators. You can have your technologists testing different kind of operational settings. And the difference that you see between this one and this one is that this looks something at what an operator is used to seeing, and this is about what he is seeing, but it's not actually the same screens that he is behind. So what we have, the latest development that we have done in the last months is to research whether we can couple this simulator that calculates the water quality throughout the system, and you can change all settings of chemicals, of water quantities, and see if we can link it to a copy, an emulation of the real SCADA system. And that's a nice development, and maybe for next time I can tell a little bit more about that. What we also do with models is that we use them for designing, and it can be from fairly simple to very complicated, and every agency that designs processes, treatments, uses these models to design. So that's nothing new. But what is a nice example, I think, is that we also evaluate designs of installations with models. So, for instance, it was already from work done a few years back. But there was a new design of a treatment plant, and it was before it was built, it was actually modeled. A diurnal pattern of wastewater that would be coming in there was measured. So with all the different characteristics for N and P and flows, and it was fed through this model, and it was seen whether the dimensions could be a little bit smaller or to optimize, further optimize the design. Well, the study showed that wasn't possible, so it was a good design, but it shows what you can actually the power of these applications. Then something about the benefits of technology. And as far as I'm concerned, they're in its application. The value of it is that what we see a lot is that you can increase utilization of your installed base. If the largest savings you can make is by not expanding your treatment facilities, but by having them running them with higher loads. And in the past few days, I've seen quite some nice examples of innovative ideas to increase capacity of wastewater systems. So that's really really a powerful tool for cost efficiency, and also for having a better use of your process knowledge that you actually incorporate in this models. And well, that's the goal here. We shouldn't model just because we like modeling, but we have to keep in mind that it has to lead to a higher product quality, lower cost, and lower environmental impact. Some benefits more additional is that by modeling, because we did a very large project. And we built this plant-wide model, and it took quite some time. It was a PhD project, and it always takes at least 4 years, and usually longer. And we did a lot of research, and within this time, things changed in a treatment plant. So, at the end of this project, we heard, yeah, well, nice with this model, but no one is sitting behind it at this moment. So what did it bring us, all this money? And then we were thinking, well, in this time this changed, and this changed, and this changed, and yeah, but that just came on, and we did. But people don't realize that a lot of knowledge was gained, and it was shared with the other with the people that are doing it, and a lot of changes that actually from knowledge that came from these projects were incorporated, and higher efficiencies were already installed. So, well, I think by now you have read all the bullets. Maybe what is nice to point out is that a process is less sensitive for disturbances. Because if you look at water at the water quality, and you look at online measurements that are taken, then you see that the best thing for a process is to operate with as less disturbances that you want. I've seen sometimes from plants in the US where they measure, for instance, turbidity, and you see every shift. Someone showed this picture. Every shift of an operator, you saw the turbidity going up and down and up and down, and then after a while it was steady again, and a new shift, and it went up and down and up. So they came and said, oh well, this is not the way I'm used to it, and we're going to change some things. And all these disturbances are eventually giving loads of particles, etc., into your distribution system. So by eliminating these kind of disturbances, and this is the human disturbance, and it's quite a large disturbance in our processes. And if you go to for instance, to a model-based control, these disturbances will eventually, when you have it running right, and I'll imagine that before you'll have it actually really running right, there will also be still some disturbances, but it will be eventually better for the way you operate your facilities. And maybe what is nice, well, I'll go back to the last slide, because what's my time? Okay, it's also time. This is also my last slide, the future perspectives, and that is that. What I showed you, we are in the process of developing a vision and a strategy on this subject for WaterNet. And later on, Rob Schotsman will present a vision that he has and share it with us. So it will be very nice to be hearing that. And IT and water is probably going to be a new focus theme at WaterNet. And there is a new water network theme group in Schagen, and it's IT applications in the water sector, and it is for our Dutch WaterNet network. So this is what I wanted to share with you, and well, this didn't have a picture, so this is all right. And I would like to thank you for your attention.